Alright, today we are going to find the volume of a solid generated by revolving the shaded region about a vertical line. So let's take a look at question number 1. The question said that find the volume of the solid generated by revolving the shaded region about the y-axis. So this time, the y-axis is going to be the axis of revolution. So this is a y-axis. It has equation x equal to 0. Now, that means we are going to rotate this way, left and right. It's still going to be circular motion. The cross section will be circles. Now we are going to see for this shaded region, the smallest y value is going to be 0. The biggest y value will be 2. So we're going to pick a point between 0 and 2. So we pick a point over here. We are going to use this as the center of the circle. So we're going to draw from here to the curve. The first curve we hit, then we stop. So this is going to be the small radius. Now you will find out that the small radius is horizontal because we're doing left and right. So for horizontal, then we have to use the x subtract x. This line is x equals 0. How about this curve? We have y equal to square root x. We have to solve for x. So we have to square both sides. So we get x equal to y squared. So now we say that the small radius is the distance between x equal y squared and x equals 0. To get a positive radius, we do right minus left. So therefore, r equal to y squared minus 0. The x will be canceled out. So r equal to y squared. So we found the small radius. Now we have to find the big radius. So we're going to go to this point over here. We are going to draw, and we pass the first curve, we go to the outer one. So now this one here is x equal 4. This line is x equal 4. From x equal to 0 to x equal 4. So the big radius is going to be the distance between x equal 4 and x equal to 0. So the big radius is going to be 4 minus 0. The x cancel out. So big radius is 4. So we find the big radius in the small radius. Now we're going to draw one cross section. So this time it looks like this. Next, we're going to use volume equal to integral. So it's the same concept. It's A to B, area of cross section. Because this time you have a horizontal radius. So for each little height over here, like when we talk about little disk, so little height is going to be delta y. So therefore we're going to use dy. That's the only difference. Because we have the area of the cross section is going to be the big circle, subtract the small circle. So it's still going to be integral A to B, pi big R squared minus pi small r squared and dy. Now we are going to factor out or bring the pi outside, A to B. So A is going to be the smallest y value because you can see it is horizontal, and then B equal to the biggest y value. So you go back to this shaded region over here, you can see it. The smallest y value is 0, the biggest is 2. So therefore it's 0 to 2. And we found the big radius 4, so 4 squared minus. And then we had the small radius is y squared, so it's y squared holding square dy. You can do it by hand, you can use a calculator. So to do this in a calculator, you just have to replace the y by x. So we do math 9, 0 to 2, and then we get 4 squared minus parentheses x squared holding square, and then dx. You just replace the y by x. do a math frac. 128 over 5. So therefore the answer is 128 over 5 times pi. So we found the answer. Now let's take a look at question number 2. Number 2. Find the volume of the solid generated by revolving the shaded region about the vertical line x equal to -1. Then we had to draw the line x equal to -1. So here's -1, so we're going to draw the vertical line x equal to -1. Now the shaded region is the same one over here. So now we are going to put a dot over here, and then we're going to hit the first. This is going to be the small radius, and then we say that the small radius is going to be the distance between x equal to y squared and x equal to -1. So in order to get a positive, we do right minus left. So we're going to subtract, x cancel, so you get y squared minus -1. Simplify, you get y squared plus 1. So we found the small radius. Now we're going to find the big radius. So you go back to the same point and you're going to draw, you pass the first curve, you go to the second one. This one is x equal 4. So that means the big radius is going to be the distance between x equal 4 and x equal to -1. So now the big radius you can subtract. So you get 4 minus -1. Simplify, so you get 5. So we found the big radius. Now you're going to draw. You will find out that it looks like this. Okay, so very similar to what we did before. Volume equal to integral a to b, area of cross section dy. That's the only difference. Now we are going to find the smallest and the biggest y value. So the smallest is y equals 0. The biggest is 2. So therefore you're going to get integral 0 to 2. The area of the cross section is still going to be pi big R squared minus pi small r squared dy. So we factor out the pi, and then the big R is 5, so you get 5 squared minus small r squared. Small r is y squared plus 1. So now we got 5 squared minus parentheses y squared plus 1 holding squared dy. Now next step is to type it into the calculator. Math 9, 0 to 2, and then you get 5 squared minus parentheses, and then you're going to do x squared plus 1 holding square, and then dx. And then you're going to do a math frac. So you will get 544 over 15. So therefore the final answer is 544 over 15 pi. So we finished.